Hello and welcome back. Today we will evaluate the limit as x approaching infinity of 1 plus a over x to the power of bx, where a and b are constants. This is actually a hard problem that we need to use the hospital rule, and then we have to use our brain, because if we directly substitute x to infinity, we will get something like this. So in this video, whenever I do a substitution, I will put down the number. So our first try of substituting x to infinity. So x to infinity. So what we will get? We will get 1 plus a divided by infinity to the power of b infinity. Now whenever we have something divided by infinity, we get 0, so that 1 plus 0 is 1, to the power of b infinity is the same as infinity, so we get 1 to the infinity power. But this right here is actually indeterminate. This right here is actually indeterminate. So that means we will need to do some work to this limit. Now we see an exponent here, so that maybe we would want to bring the power down by using natural log. But before using it, we will need to set n to be the solution of this limit. And let me write that down for you. Now n is equals to this limit, so that we can take natural log of both sides. It is still the same. But natural log is continuous, so that actually we can swap the limit and the natural log, so that we end up getting the limit as x approaching infinity, natural log of 1 plus a over x to the power of bx. And then, because we have natural log, we can now bring the power down here. This is one of the log property. And then we have limit x approaching infinity, bx multiplied by natural log of 1 plus ax. Now maybe we can stop and try to substitute x to infinity. So this is our second try of substituting x to infinity. Can we get an answer? Let's try. b multiplied by infinity times natural log of 1 plus a over infinity. b infinity is the same as infinity. And then 1 plus 0, so it is 1, but natural log of 1 is 0, so that we end up getting 0 multiplied by infinity. Now this right here is also indeterminate. So we need to do more work. Right, so we need to do more work on this limit. Let me use another paper. So now we have the natural log of the solution is equals to the limit as x approaching infinity, bx multiplied by ln 1 plus a over x And then we have tried to substitute x to infinity. That doesn't work. So when we encounter 0 multiplied by infinity, we usually try to move one of the x to the denominator. Now this x is inside the natural log. If we can have a choice, we would like to choose this x. So how can we put this x into the denominator? That's not hard. Normal algebra. We just need to write the x in the denominator with the reciprocal. So this and that are the same. Do you agree? Now, after we put the x in the denominator, that usually fixes this. So maybe we can try to sub x to infinity. This is our third trial. We will get b multiplied by natural log of 1 plus a over infinity divided by 1 over infinity. So 1 over infinity is 0, and then b multiplied by natural log of 1 plus 0, which is natural log of 1, which is 0. So this is also 0. And then we end up getting 0 divided by 0. This right here is undefined, but this is a lot better than the previous trial, because whenever we have 0 over 0 or infinity over infinity, we can use the L'Hospital rule. We just need to write down the reason here. So L'Hospital rule is when we substitute in the x and then we get 0 over 0 or infinity over infinity, we differentiate the numerator and denominator. So we now differentiate the upper one also the lower one. This is x to the -1. I forgot to put down the limit, but that's okay. We want to work out the derivative of them first. The derivative of the upper one will be b stay the same, and then the differentiate the right hand side, which is 1 over 1 plus ax. But the chain rule says that we should also multiply by the derivative of the inside. So we will want to differentiate 1 plus a over x. Differentiating 1, of course, we get 0. So we differentiate this, we get negative a over x squared. And then we differentiate x to the -1 power, we get negative x squared over 1. This is not simple differentiating skills. So that our question now becomes the limit as x approaching infinity, and then b multiplied by 1 plus ax multiplied by negative ax squared all over negative x squared over 1. So now we have 2x squared in both of the numerator and denominator. So if we want to cancel that out, maybe we can multiply by x squared on the bottom and the top. So they cancels out, and then 2 negative become positive, so that our problem is now much easier. We just left with AB multiplied by 1 over 1 plus AX, which is the same as AB over 1 plus AX. But do you remember x is infinity, so it is 0, and then 1 plus 0 is 1, so that our answer is AB. Now, actually we haven't finished the problem, because do you remember, we take the lateral log at the beginning, so that means the natural log of the solution equals to AB. And then to cancel out the natural log, we take e to the power of both sides, and they cancels out, so that our final solution is e to the power of AB. And then our conclusion will be the limit as x approaching infinity of 1 plus a over x to the power of bx is equals to e to the AB power. And that's our answer. Thanks for watching.